Okay, so a couple of things in this video. We're going to look at direct proportion, and we're going to look at something called the constant of proportionality. Now, first of all, we've already covered direct proportion. You'll remember that direct proportion is a proportion between y and x so that our graph passes through the origin. It'll take the form y equals mx because there's no, or the y-intercept is 0, so there's no c here. That's direct proportion. Now we can write y is directly proportional to x. It's a mouthful, but we've got a little symbol for it. Y is directly proportional to, get rid of that. Y is directly proportional to x. Okay, so remember that symbol, is directly proportional to. Now I wanted to briefly talk about something called the constant of proportionality, and the constant of proportionality is a special name for the gradient of a direct proportion. The constant of proportionality only exists in a direct proportion, and here it is here, m. Now, given this new terminology, this new way of writing things, and this new idea, the constant of proportionality, there's a couple of bits of math that we can do. Let me show you a couple real quick. So here's a quick example. If y is directly proportional to x, x equals 3 and y equals 12, find the constant of proportionality. Now we know that the constant of proportionality is that thing. If it's directly proportional, we know it can be written as y equals mx. And we also know that there's a point on it, sub x equals 3 and y equals 12. Sub 3, 12 into the equation, and we end up with 12 equals m times 3. 12 divided by 3, that means that m equals 4. The constant of proportionality in this case is equal to 4. So that's one way that we can use this constant of proportionality idea. How else could we use it? The second way that we can use it is to test for direct proportion. In other words, if you're given a table like this, is x and y directly proportional to each other? Now we can test that because we know that direct proportions always look like this, y equals mx. And we know there's no c value, and we know that m must always be the same. So all we need to do is sub in each of these points. Now I'll sub 1 in here. First I'll rearrange it. I rearrange it so I can find out what the constant of proportionality is. As long as the constant of proportionality remains constant, then I know it's a direct proportion. Okay, so y on x, that's 3 on 1. Test this other one here. Y on x equals m. That's 6 on 2. The next one is 9 on 3. The next one is 12 on 4. The next one is 15 on 5. All of those are equal to 3. So m is equal to 3 here, 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 and m is equal to 3 here. Therefore, and this is the big finishing move, therefore y is directly proportional to x. That's direct proportion and the constant of proportionality. Two things you can do with it. If you are told two things are directly proportional, you can find out what the constant of proportionality is, and if you want to find out if two things are directly proportional, test out each point, find out if there is a constant of proportionality, if the m is the same for each of the 5 points. It would only take 1 point to ruin the whole thing. As soon as I turn that into a 16, 16 divided by 5 is not going to be 3, so therefore x and y are not directly proportional. Alright, that's our direct proportion and the constant of proportionality.